Typically, when thinking of statistics, we tend to conjure up a mental image of a stuffy, underventilated classroom, lots of writing, and millions of graphs. While this may be true in some capacity, that's merely scratching the surface of what statistics is for. Statistics quietly powers many of the decisions we have to make on a daily basis. This includes anything from sports, to social media, to healthcare, and more. As such, let's explore a couple real-world scenarios where statistics is able to help us understand more about them. Problem 1. Blood pressure medicine. Imagine a pharmaceutical company develops a brand new medicine that they believe lowers blood pressure more as opposed to the current prevalent treatments. But how can they use data-driven insights to support the fact that it actually does? This is where statistics comes in. Let's say 200 patients are randomly chosen to participate. 100 receive the new drug and 100 receive the old drug. After 1 month, researchers measure the average decrease in blood pressure. At first glance, the new drug appears better. Patients taking it saw an average decrease of 14 millimeters of mercury, compared to only 10 for the old drug. But this is merely from a sample size of 200 people. How can we be sure that this wasn't a result of random chance rather than due to the medicine? To answer that question, statisticians perform a hypothesis test. The null hypothesis assumes the status quo. There's no difference between the drugs. The alternative hypothesis would be what the scientists aim to prove, which is that the blood pressure from using the new drug is less than that with the old one. After running the calculations, researchers obtain a p-value of 0.02. Since 0.02 is smaller than the commonly accepted significance level of 0.05, we reject the null hypothesis. That means the evidence suggests that the new medicine truly is more effective. Statistics allows us to draw conclusions in medicine with evidence and data, rather than relying on small sample sizes and surface-level conclusions. Problem 2. Sports analytics in basketball. Statistics is also very present when it comes to things like sports. Basketball teams rely heavily on data to make important decisions such as pregame strategy, what players to sign on, etc. A coach is deciding whether a player should opt to take more two-point shots or more three-pointers. At first glance, 45% is a higher percent than 38, so it would be reasonable to assume that taking more two-pointer shots would be the right move. How can we be sure of this, though? Statistics helps us gather evidence. A two-point shot only gives 2 points, while a three-pointer gives 3. Rather than just taking the percentages at face value, we calculate the expected value of each shot given the fact that they award different points. The average expected points from a two-point shot is 0.90 points, whereas in a three-point shot, it's actually 1.14 points. Although the player makes fewer three-pointers, they will get more points in the long run from consistently shooting three-pointers instead of shooting two-pointers when you factor in the amount of points that you get from a three-point shot and the percentage. Statistics allows us to look past the face value percentages to see long-run outcomes, and in doing so, basketball teams are able to make smarter decisions on what to designate their players on and their game strategies, and pharmaceutical companies are better able to decide whether their pharmaceutical works or not and to what degree.